Okay, gentlemen, we are going to talk about how do you find missing sides of a triangle when all you know in a right triangle is one side and one angle. Remember, that idea of knowing one angle is that we know one of the acute angles in a triangle because we're talking about right triangles. So, let's take a look at a right triangle here. Let's say we know this angle down here is 25 degrees and we know this side here is 7 centimeters. Obviously not drawn to scale. Now remember, it's easy to find this angle. We know the angles of a triangle add up to 180. We know in a right triangle the two acute angles add up to 90. So you can find 65 quickly by taking 90 minus 25. But if I had asked you to find this side here, x, or this side here, z, we're not going to be able to use the Pythagorean theorem because we only know one side. But what we can use is the relationships we've been talking about in right triangle trigonometry, that the sine of an angle is equal to the opposite over the hypotenuse, that the cosine of an angle is equal to the adjacent over the hypotenuse, that the tangent of an angle is equal to the opposite over the adjacent. So when we come back over here and we look at our triangle, we know two angles. We know 25 and we know this other angle, 65. Now choose whichever one you like. It doesn't matter. I'm going to choose 25 for no reason other than I like it. And I'm going to look at this angle and I'm going to look at the side I know and I'm going to pick a side that I want to solve for. I'm going to solve for the hypotenuse first. I'm going to solve for z. So if I know 25, I know that this is the opposite side of 25 and I know this is the hypotenuse. So if I look at all my trig functions, I'm looking for this trig function that uses opposite and hypotenuse. You may have already said it out loud, that's sine. So what I'm going to do is I'm going to write that the sine of 25 degrees is equal to 7 divided by z. Good? Now, the sine of 25 degrees is a number that we would get from a calculator. So what I have is a number equals 7 over a variable. Right? And let's just think, instead of a, you can even just think some number. Now if you had to solve this, all you would want to do is multiply both sides by z. That gets it to cancel here and cancel here. Now you have z times a number equals 7. Then you would just divide by that number. Those would cancel out. You'd have to divide this side by a number. And you would get that z equals 7 divided by that number. You do the exact same thing over here. Multiply both sides by z, and you get this equation, z times a number, that number is called sine of 25 degrees, equals 7. The z's have canceled on the right hand side of this equation. Divide both sides by that number, which is sine of 25 degrees. So I better do that over here. Sine of 25 degrees. So I get z is equal to 7 divided by the sine of 25 degrees. Without a calculator, you couldn't do anything else. So I'm reaching for my calculator right now. I'm checking that I'm in degree mode. Once I make sure I'm in degree mode like we did yesterday, I'm going to take the 7 and I'm going to divide by the sine of 25, and I get 16.5634 blah blah blah. So let's round to 3 decimal places. 16.563. Now, I don't know if I'm right, but one thing I do know is that if I look at my right triangle, I got that the hypotenuse is 16.563. At least it's bigger than the opposite side. So that's a pretty good start. Alright, I had to clean up that slide so we could do some more work. Let's review what we know. We've got this right triangle. We were given that this was 25 degrees and that this was 7 centimeters. We calculated that this hypotenuse using the sine of 25 and the opposite over the hypotenuse relationship, that this was 16.563 centimeters. We used a little geometry to figure out that this was 65 degrees. And now what I want to try to figure out is, what is this third side x? You could use the Pythagorean theorem. You know two sides. The problem with using the Pythagorean theorem is we came up with this side, and if we had made a mistake here, then we're going to make a mistake here. So I want to go back to the original information that's in the black marker. I know this angle is 25 degrees. I know the opposite side is 7 centimeters, and I want to find the adjacent side to that angle, x. So what I would like you to do in this situation is use the relationship that the tangent of 25 degrees is equal to 7 divided by x. Instead of using the hypotenuse that we came up with and maybe making a mistake finding x if we made a mistake up here. This way, if we made a mistake with the hypotenuse, we're not going to use that mistake to find x. It doesn't matter in the long run if you're not making mistakes, but this will get us practice using other trig functions and solving for variables. So again, to remind you, the tangent of an angle is just a number. X is the variable you're trying to solve for. To get rid of x in the denominator, we want to multiply both sides of the equation by x. That clears the fraction on the right-hand side and gives us an equation that looks like x times a number equals 7. X times this number, tangent of 25 degrees, equals 7. Now I'm going to take both sides and divide by this number to get x by itself. So I'm going to divide by the tangent of 25 degrees. So I have to do that over here. Divide by the tangent of 25 degrees. I end up getting that x is equal to 7 divided by the tangent of 25 degrees. Without a calculator, I can go no further. I want you to write this answer down exactly like this, and then I want you to reach for a calculator, do 7 divided by the tangent of 25, and get about 15.01154 blah blah blah. So round to 3 decimal places, 15.012 centimeters. Now, if we look at the entire problem, I don't know if what I got was correct, but what I did find out about these sides makes intuitive sense to me. The smallest angle of the triangle is opposite the smallest side of the triangle. The largest angle in the triangle is opposite the largest side, and the medium angle is opposite the medium side. One way to check your answer is to take 7 squared and add 15.012 squared. Take the square root of that sum and see if you get something close to this. Now, if you use the Pythagorean theorem with these rounded answers, it won't be exact, because the only exact values was 7 divided by the tangent of 25 degrees. This is a rounded answer. All right, what I'd like you to do now is I'm going to give you a problem. I want you to pause the video when I say pause, or I'll write it on there. And then I want you to work the problem out on your own and then follow the video to see if you get the correct answer. So, I'm going to give you a right triangle. I'll tell you which angle is the right angle, always. I'll tell you how big this angle here, it's 33.2 degrees. And I'm going to tell you that this side right here is 8 centimeters. What I want you to do on your own is I want you to solve for this side C, and I want you to solve for this side B using right triangle trigonometry. Pause the video now. Okay. Doesn't matter which one you solve for first. For no reason, I am going to solve for B first. There's no reason why I'm solving for B other than I want to. I know this angle, 33.2. In relationship to this angle, this is the opposite side. And this side I know is the adjacent side. I'm going to then use the trig function tangent of 33.2 degrees equals the opposite side B divided by the adjacent side 8. This is a pretty easy problem because all I have to do to solve for B is multiply this side by 8 and multiply this side by 8. When I do that, I get 8 times the tangent of 33.2 equals B. I now just use my calculator and I find out that the tangent of 33.2 times 8 is about equal to 5.235. Because this side is measured in centimeters, I know B is also measured in centimeters. Good? All right. Now to solve for the other side, C. Looking at the right triangle and the information I know, knowing that this side is 33.2, I know the adjacent side, and I'm looking for the hypotenuse. So, the trig function that uses adjacent and hypotenuse is cosine. So I'm going to say the cosine of 33.2 degrees is equal to 8 divided by C. Now, I multiply both sides by C. That's because this variable in the denominator, I want to get out of the denominator. I now have a variable times a number. That number is cosine 33.2 degrees. I need a calculator to figure that out, and that's equal to 8. If a variable times a number equals 8, then that variable is equal to the number 8 divided by cosine of 33.2 degrees. Again, I reach for my calculator. I do 8 divided by cosine of 33.2, and I get that C is about equal to 9.561 centimeters. The last thing I do is a mental check. The largest side of the triangle, the hypotenuse, is the largest number I calculated. The smallest side opposite the smallest angle is 5.235. The one thing I haven't done, what I haven't done here is I have not calculated the angle that's missing. So if I do that real quick by taking 90 minus 33.2, I get that the other angle is equal to 56.8. So this angle up here is 56.8 degrees. The reason I calculate that is the side in the middle of all three sides, 8, is opposite the medium angle, the second largest or the middle angle. So like I said earlier, not 100% sure I'm correct because, you know, I can't ever be 100% sure, but at least my answers make sense, right? And, you know, to be honest, I'm 100% sure these are correct. That's how you solve for a missing side when you only know an acute angle of a right triangle and one side using sine, cosine, and tangent. Hope you guys have a great weekend. Thanks for watching the video. Peace.